Welcome to today's lesson. I am Masaka Kirendens, and so today I am going to take you through a lesson where we're going to look at actually the chemistry. Lesson basically will look at subatomic particles and isotopes. And so we go straight into the lesson. Well, subatomic particles are actually three particles which are found in an atom, and these particles actually which are found in an atom are actually three of them. We have the protons, and two, we have the neutrons, and three, actually we have the electrons. So an atom is made out of actually three subparticles, these three subparticles. And the location of these is that an atom actually has a nucleus. So this is the nucleus of an atom. And then around it, it has shells. It has shells. An atom has shells around it. Okay. So these three particles actually, the protons are found inside the nucleus, as well as the neutrons, while the electrons are found in shells, that is around the nucleus. So this is very important because we need to know actually where these particles are found. So as I stated earlier on, we have these three subparticles. We have the protons, and the mass of the proton is actually 1, and it has also a charge of 1. And it's located, it's found in the nucleus. So the protons have a mass of 1 and a positive charge, which is charge 1 and the nucleus. And then the neutrons are actually have a mass of 1 and they have no charge, and they are also found in the nucleus. While the electrons are found, as we indicated, in shells, that is around the nucleus. And the electrons have a charge of -1, and they have a very small mass. So we state that actually we have a negligible actually mass. So actually, as we stated, the protons, but to summarize this, the protons, the mass is 1, then the charge is actually +1, and they are found in the actually nucleus. While the neutron have also a mass of 1. Then the charge is actually 0. and they are found actually also in the nucleus. Then we have electrons. The electrons actually have a mass which is very small. And then the charge of electron is -1. And they are found around the nucleus or in shells. So this is very important. This is very basic information that learners should have. And so an atom actually, this symbol X here is representing actually the atomic symbol. It's a symbol of actually an atom. And so the top part, which is A, is actually the atomic mass. The atomic mass is also known as the mass number, or actually the nucleon. Number. So, and then B is the actually the proton number, or we can say actually this is the proton number, or we can say it's the atomic number. Okay, so that's what it is actually. This is the atomic mass. And then this is the proton number. Okay, so actually the nucleon number is the same as the sum of actually the protons and the neutrons. So when you add the protons plus the neutrons, actually you get the atomic mass. So the nucleon number is the same as actually the atomic mass as we indicated, and it's the same as the mass number. Okay, and so we now look at the isotopes. What are isotopes? Isotopes are actually atoms of the same element. So it's an atom of the same element, but this element is going to have different neutrons. Okay, so actually the neutrons, when added to the protons, they give us the atomic mass. And so when the neutrons are different, it means that the atomic mass is going to be different. So it means that they have the different atomic mass or nucleon number or mass number, because actually an isotope is the same element but with different actually neutrons. As we indicated, the protons plus the neutrons will give us actually the atomic mass. The atomic mass is also known as the nucleon. Nucleon number. Also, it is known as the mass number. So here, what differentiates the atom would be actually the number of neutrons. And since the number of protons remains the same, and these would be different, it means that you are getting actually the different atomic mass, nucleon number, or mass number. So basically, that's the meaning of what an isotope is. And so generally, isotopes, since they have the same number of electrons in the outermost shell, because of the same proton number, so basically, we expect that they have the same chemical property, they react in the same actually manner. So generally, at O level, we can say actually the isotopes react the same, meaning that the different atoms of the same element will react the same. However, there is an exclusion criteria where some heavy isotopes actually with very large mass, they have actually different properties because their rate of reaction is actually different. And this can be actually verified from the kinetic isotope effect. That is where actually the same element or the same atom, it is reacted with another species with the different isotopes. And you find that actually the masses would be different of what is produced. And this is what is known as the kinetic isotope effect. But generally at O level, what we should know is that actually the atoms of isotopes actually generally they have the same chemical properties. And the reason is that they have the same number of electrons in the outermost shell, because the reaction is dependent on actually number of electrons. Okay. And so these species actually are showing the types of isotopes. For example, chlorine. Chlorine has two isotopes, as we have shown here. So what will be different here is that when you subtract 35 minus 17, it will give us actually neutrons. It will give us actually the number of neutrons that we get. That is the atomic mass minus the proton number. Similarly, even here, 37 minus 17, which is actually 20, is going to give us actually the number of neutrons. So we note that here, actually 15 minus 7, 85 minus actually 17, that's 15 minus 7 is actually 8. And 2 minus 1, that is 18. So, which is actually 18 neutrons. So this is how different actually isotopes are. They differ in the number of neutrons, and yet the number of protons remains the same. So these are the number of protons. And similarly here, these are the number of protons. And this is the atomic mass. And this is also the atomic mass. So this is actually what it means. And so isotopes of carbon, similarly, also we have these atomic masses. And so here, if you are to find the number of, you find here, that would be 6 neutrons. And these are actually protons, the number of protons. And this is the atomic mass. Similarly, for this one, it will be actually 18 minus 6, which will definitely be 7 neutrons. And these are the protons, and this is the atomic mass. Similarly here, we are going to have 14 minus 6, which is actually 8 neutrons. And these are the protons, and then this is the atomic mass. And so generally from here, you can see that actually isotopes have the same number of protons, but they have different number of neutrons. Similarly, finally, you see here protium, which is actually hydrogen with the 1 atomic mass, and the deuterium, which is actually another hydrogen with the atomic mass of 2, and the tritium, which is another hydrogen with the atomic mass of 3. And so similarly here, we would say 1 minus 1. Meaning here we have 0 neutrons, the number of neutrons here. And then here we are going to have 2 minus 1, which would be 1. And then 3 minus 1, which would be actually 2. So you not see generally here that actually what differs an isotope is the same element, but with different number of neutrons. And so there are basically 2 genotypes of isotopes. We have stable isotopes and unstable isotopes. Generally, the stability of an isotope is dependent on the number of neutrons in it. The isotopes with the very few number of neutrons and very many number of neutrons are actually not stable. So, so if the neutrons are very few and too many, it means that actually an isotope will easily decay or it will easily disintegrate. However, when an isotope actually has a moderate number of neutrons, is actually stable, and therefore it cannot easily decay. And these stable isotopes actually can be used in environmental and ecological experiments. So when you do experiments, you can actually use them. The other type of isotopes are the unstable one, and generally these unstable isotopes actually are radioactive in nature because they easily decay and they easily actually emit alpha, beta, and gamma rays. Okay, and so they will actually emit these rays. So actually radioactive isotopes can also be classified according to how they are formed. We have radioactive isotopes which were created actually during the emergence of the creation of the solar system, and these are known as long-lived radioactive isotopes because they have been there for a long period of time. They are known as long-lived radioactive isotopes. They emerged during the creation of the solar system. And then you have those which are formed as a result of the reaction of the atmosphere with the rays from the stars. That is the cosmic rays from the stars. When they react with the atmosphere, then we have what are known as cosmogenic radioactive isotopes. So cosmogenic radioactive isotopes are actually formed as a result of the reaction of the atmosphere with the rays from the sun and the stars. And then we have the radioactive isotopes actually, which are formed by human-made activities, and these are known as anthropogenic isotopes. So anthropogenic isotopes actually are those which are made by man. And so the radioactive isotopes have a range of uses. They can be used in agriculture. They can also be used in the food industry, pest control, as well as archaeology, as well as in medicine. And so today, I thought maybe we look at one, the subatomic particles. Which we said actually there are three. We have actually the protons, we have actually the electrons, and then we have the neutrons. So the protons actually have a mass of 1, while the electrons, we can say is very small. We can say the mass is actually 0. And then the neutrons have a mass of 1. Then the protons actually, they have a charge of +1, while the electrons actually, they have a charge of -1. And the neutrons actually, they have a 0 charge. And we said actually the protons are found in the nucleus and the electrons are found around the nucleus in shells, while the neutrons are found also in the nucleus. And then from there we looked at the isotopes, and we said actually isotopes are the elements of atoms of the same element, but with different actually number of neutrons. That's what we said. And so generally today, I said we look at isotopes and the subatomic particles. So I hope you subscribe actually to my YouTube. And so those who want to actually contact me for more intensive lessons, you can contact me through my number, my WhatsApp number, which is 260-97741-9949. So we can now talk on how we can feed you these lessons online. I thank you.